Here I explain the FIR direct form structure with an example. Here, for example, I use the transfer function or the system response h of z is equal to 1 plus 4z inverse plus 5 into z raised to minus 4 plus 3 into z raised to minus 5. From the definition of transfer function, we know that h of z is equal to output by input. Let us take x of z is the input and y of z is the output. Now, the system function h of z become y of z by x of z, that is output by input. Let us replacing the above equation number 1 by this equation. We got y of z is equal to x of z, y of z divided by x of z is equal to 1 plus 4z inverse plus 5 into z raised to minus 4 plus 3 into z raised to minus 5. Multiplying both sides by x of z, we got y of z is equal to x of z plus 4 into x of z into z raised to minus 1 plus 5 of x of z into z raised to minus 4 plus 3 into x of z into z raised to minus 5. By taking the inverse z transform, we got y of n is equal to x of n plus y of x of n minus 1 plus 5 into x of n minus 4 plus 3 into x of n minus 5. From this equation, from this last equation, we clear that mainly there are three mathematical operations. First one is addition, second one is multiplication, and third one is delay network. Here I explain the realization of FIR system in direct form, how to draw direct form structure. We know that y of n, that is a differential equation, y of n is equal to x of n plus 4 into x of n minus 1 plus 5 into x of n minus 4 plus 3 into x of n minus 5. Now I start to draw direct form structure. We know that the input is x of n. So from here I wrote down one line. From that, the next sequence is x of n minus 1. For that we need a delay, that is z raised to minus 1. From that delay network we got x of n minus 1. And next function is x of n minus 4. So I wrote another delay z raised to minus 1 where I got x of n minus 2. Then another delay z raised to minus 1 there I got x of n minus 3. Next another delay z raised to minus 1 where I got x of n minus 4. Then the next sequence is x of n minus 5, that is z raised to minus 1. There I got x of n minus 5. That is, after the first delay network, the sequence is shifted by 1, that is x of n minus 1. Then after the second after the first delay we connect 3 delay. Okay, that is for x of n minus 2, then x of n minus 3, and after the 3 delays we got the sequence shifting is x of n minus 4. Then next one is another delay, and we got after the delay we got x of n minus 5. Then in the first sequence we know that there is x of n, there is a multiplier or a coefficient that is 1. That coefficient is 1. After the sequence, in the second sequence, there is a coefficient. That coefficient is 4. So I wrote down 4 here. And these two are summed up. And I use an adder here. Okay. Then after the second delay network, there is no sequence in our example. And after the third delay, there is no sequence in our example. After the fourth delay, we got x raised to n minus 4. That is, there is a coefficient. That coefficient is 5. And this signal is, or this sequence is also added by the previous one. That is this one. Then next one is x of n minus 5. That is also multiplied by a coefficient, that is 3, and is also added by using an adder. And finally we got the exact sequence. We got the exact sequence, that is y of n. This is the tapped form of FIR direct form, FIR direct form realization. FIR direct form realization. Here I explain the transposed version of direct form structure from the same example. Y of n is equal to x of n plus 4 into x of n minus 1 plus 5 into x of n minus 4 plus 3 into x of n minus 5. Here x of n is there, then that x of n is connected to first delay network, that is Z inverse. From that Z inverse, we got a delay x of n minus 1. We got x of n minus 1. Again I use another delay Z raised to minus 1. From there we got x of n, another delay x of n minus 2. Again I use Z raised to minus 1. From there we got the delay x of n minus 3. Again another delay, that is Z raised to minus 1, and this delay will give x of n minus 4. And finally I again draw another delay Z raised to minus 1, and this delay network gives x into n minus x of n minus 5 seconds. And from the example, x of n, the coefficient of x of n is 1. So here I wrote 1. And from the example, the coefficient of the second sequence, that is x of n minus 1, is 4. That is 4. And these two are added. Then there is no coefficient for x of n minus 2, x of n minus 3. And for x of the coefficient of x of n minus 4 is 5. And this is added with this network. There is also a summer. And this final sequence x of n minus 5 is also added with the previous one, and this the coefficient of the sequence x of n minus 5 is 3, and this is the y of n. See, this is the transpose version of direct form structure.